Good day, sir. My name is Carlos Juan from ESMB. So I'm here in front to discuss about how to solve the homogeneous differential equation and problem number one. So 2x dy equals to x plus y dx. So it is called homogeneous because the term on degree is the same. So x1 they are the same degree. And next y equals to bx. Then we need to derive it by the derivative of y equals to dy. Derivative of b equals to dv x plus derivative of x equals to dx. So final is dy equals to x dv plus v dx. So next is we need to change the variable y and the dy. So the 2x, 2x, the value of dy equals to x derivative plus v dx equals to x, the value of y equals to dx plus dx dx. Then factor out the x plus dx. This right x 1 plus v dx. And this is the left remain. Copy this one 2x x dv plus v dx. So since they are the same and variables, so x, so cancel it out, cancel. So the remaining is 2. Then distribute this into 2x dv plus v dx. So 2x dv plus 2 times v dx equals to 2 v dx equals to distribute also the dx by dx times 1 dx plus dx times v equals to v dx. So v dx. Same variables v dx and v dx. So we need to subtract it by negative v dx. So negative v dx. So over cancel this one, cancel. Then the remaining is 2x dv plus v dx. V dx equals to dx. So we need to move this one to the right side. So 2x dv equals to dx minus v dx. Then factor this one, the factor of dx. So 1 minus v dx. Then copy the 2x dv. So since there's the value of 2x dv equals to 1 minus v dx, we need to divide it by 2x, 2x, and 1 minus b, 1 minus b, 1 minus b. So cancel 1 minus b, cancel 2x. So the remaining is 1 over 1 minus b dv equals to 1 over 2x dx. So that's why we can integrate. So 1 over 1 minus b dv equals to 1/2 integral of 1 over x dx. So that's it. So for now, the answer of integral of 1 over 1 minus b dv equals to ln. So ln ln 1 minus b equals to 1/2 the 1 over x equals to ln x ln x plus c. So we can also change this -1 into exponential. So ln equals to 1 minus b, exponent is -1, then equals to 1/2 of capital ln. So the x becomes to the square root of x plus ln c. So according to the law of natural log, so we can differentiate into ln a plus ln b equals to ln a b. So copy the ln 1 minus b -1 equals to, so ln a and ln b, so ln c square root of x. So next is we can change this into positive. So ln equals to, we can bring down this 1 over 1 minus b, so that the exponent become positive and equals to ln c square root of x. Okay, so since they are the same, so 1 over 1 minus b equals to c square root of x. Okay, next is since the value of y equals to bx, and since the variable is b, so b equals to y over x. So we need to change the value of b. So 1 over 1 minus y over x equals to c square root of x. Okay, so next proceed to times by x over x. Okay, so x times 1, we can get x times 1 equals to x minus y. So x over x cancelled out. So x over xy equals to capital C square root of x. Then multiply 1 by x minus y. So since they are x minus y, so cancel this one, cancel. Then the remaining is x equals to c square root of x minus y. Then square this one, since the x is square root, so squared both sides is squared, so the remaining is x squared equals to c squared. Then since the x squared plus 2, so it is main x, then the x minus y raised to 2. Since the c squared, derivative of c squared and the derivative of c equals to 0, so we can use the c constant. So the answer is divided by x. So x, so cancel this one variable. So the remaining by x equals to c x minus y squared. So the final answer is this one. X equals to c x minus y squared. So let's proceed to next problem. Y prime equals to xy over y squared x squared minus y squared. So we change in the y prime dy over dx plus 2xy over x squared minus y squared. So we can call those homogeneous because the terms of degree is the same. So the degree, second degree, x and y, and the terms of degree of x and y to the upper are also the same. So now we need to cross multiply the dy dx. So dx times xy. So xy equals to dx equals to dy at x squared minus y squared dy. Then, since we have been multiply, next process is to use the value of y equals to dx, then differentiate dy equals to derivative of d dx plus derivative of x d dx. This one is x dv. Then, so let's change the value of y and dy. So x, the value of y equals to dx equals to x squared minus the value of y equals to b squared. So b squared y squared, the value of dy. So the value of dy equals to x dv plus b dx. So the factor, since we need to factor out this one, the right side. So x 1 minus x squared 1 minus b squared times x dv plus b dx. Then copy this one, x times b times x, so dx squared dx. So since they are the same variables, cancel this one, cancel. So the remaining is b dx. So cancel, the remaining is b dx. Then distribute the 1 minus b squared times x dv plus b dx. Okay, b dx equals to distribute 1 times x dv. So x d plus 1 times b dx. So b dx. Then negative b squared minus x dv. So negative x v squared dv, then negative v squared times v dx equals to negative v cubed dx. Okay, so since v dx and this one is the same, cancel this out. Then let's move the v cubed dx into the left side. So v cubed dx equals to the x dv and negative x v squared dv. So in factor out, we have x squared. So next is divide both sides by v cubed. v cubed divided by v cubed and x, so cancel the x, v cubed, so the remaining is 1 over x dx equals to 1 minus v over v cubed dv. Okay. So since the remaining is 1 over x dx equals to 1 minus v over v cubed dv, so we can integrate now. So integral of 1 over x dx equals to 1 integral of 1 minus v over v cubed dv. So integral of x dx equals to integral of 1 over v cubed minus integral of v over v cubed, so 1 over v squared and v squared equals to 1 over v dv. Okay, so proceed to this one. So an integral of 1 over v cubed dv. So integral of this one, we need to raise this one into power rule. So integral of v cubed v negative 3. So in power rule, negative 3 plus 1 equals to integral of v negative 2 over 2, or equals to integral, or equals to 1 negative 1 over 2 v squared. Negative 1 over 2 v squared. So this one is ln 1 over x equals to ln. So ln x equals to 1 over negative 1 over 2 v squared. 1 over v equals to ln minus ln v plus c. So since the value of y equals to vc, vc equals to y vx and to y over x. So we need to change the value of v. ln equals ln x equals 1 negative 1 over 2 my value of v equals to y over x squared minus ln value of y v equals to y over x plus c. So and the law of natural log, so ln a plus minus ln b equals to ln a minus over ln b. Okay, so the answer is ln x minus 1 over 2 y squared over x squared minus ln y minus ln x plus c. So then the ln x minus 1 over equals to negative 1 over 2b squared, 2y 2y squared x squared minus ln y minus ln x plus c. So since the ln x equals negative 1, 2y squared over x squared, so divide both sides by x squared, so cancel this one, cancel, then x squared times 1 equals 2 x squared, so ln equals to negative x squared over 2y squared minus ln y minus ln x plus c plus ln x plus c. So since they are the same, cancel this one, cancel. So the remaining is negative x squared over 2y squared minus ln y plus c. So we can move this negative ln to the left, becomes positive. So ln y equals to negative x squared over 2y squared plus c. So since the ln y equals to, we will reach the exponent of e ln y a equals to 3x squared negative x squared over 2y squared times bc raised to c. So cancel this one is, then the remaining is y. Cancel down. So y equals to a negative x squared over 2y squared times a to c. So since the constant here is raised to, we need to put this in front. So the final answer is y equals to y equals to c, a negative x2 over 2y squared down 2y squared. So the final answer is y equals to c, a negative x squared 2y squared. And so let's proceed to problem number 3. So problem number 3 equals y prime equals to 2x a negative y over x plus y over x, and example that we are given point of 1 over 0, 1 and 0. So since the problem is given, we are going to change the y prime into dy over dx. So dy over dx equals to 2x a negative y over x plus y over x. So we need to cross multiply by this. So cross multiply. So dy over dx. So x dx equals to 2x a negative y over x plus y dx. So since the value of y equals to vx and the derivative of y equals to dy, derivative of v equals to x dv plus v dx. So let's change the variable y and the value dy. So x dy, so x the value of dy equals to x dv plus v dx equals to 2x a negative, the value of y equals to negative vx negative Vx over x plus value of y equals to Vx dx. So next is we need to factor out this one. So two x equals to 2a negative v plus v times dx. Then this one is x copy, it's dv plus v dx. So since they are the same and variables, we need to cancel this out. So the remaining is x dv plus v dx equals to distribute the dx. So 2a negative v dx plus v dx. So since they are also the same, v dx, so cancel this one, cancel that. So the remaining is x dv. So x dv equals to 2a negative v dx. So divide both sides by x, also x, and 2a divide 2a minus v, 2a minus v. So cancel the 2a minus v, cancel the x. So the remaining is 1 over 2a negative v dv, and this one is 1 over x dx. So 1 over x dx. So we can integrate now. So 1 over 2a negative v du. So integral of 1 over 2a negative v dv and equals to integral of 1 over x dx. So this one we can form this into positive way. So and this is a constant number, we can get this into the out. So 1 half equals to a integral of av over 2, so that the sign of negative when it comes to the upper, you can change it into positive. So dv equals to 1 over x dx. Okay, so since the value of y equals to dx and the v equals to y over x. Okay, so let's choose the variable of v. So a, the value of v equals to y over x over 2 av equals to ln 1 over x equals to ln x plus c. So we need to divide both sides by 2. So divide side by 2. So it becomes to ayx equals to 2 ln x plus 2c. So it becomes to ac ay over x equals to the 2, we need to transfer it into exponential in the variable x. So ln x squared plus or 2c, it's still constant. So we can put this one as constant or c. Since we have given a point x equals to 1, x equals to 1 and y equals to 0. So x equals to 1. So y equals to 0 over 1 equals to ln value of x equals to 1 squared plus c. So a a raised to 0 over 1 equals to 1. ln 1 squared equals to ln 1, or ln equals to 0, ln 1 equals to 0 plus c. So c equals to 1. C equals to 1. So with brackets 1. So ay, so ay over x equals to ln x squared plus 1. The value of c equals to 1. Then we need to put this one into the first. So ay over x equals to 1 plus ln x squared. So that's the final answer. So ayx equals 1 plus ln x squared. So let's proceed to another problem. So y dx equals to x plus square root of y squared minus x squared dy. So first we need to distribute the dy. So y dx equals to distribute the dy. So x dy plus square root of y squared minus x squared dy. So okay, since we have been distributed the dy, so let x equals to vy. So the derivative of dx equals to dx equals to the derivative of v equals to v dy equals to plus y dv plus y dv. So since we need next is we need to change the variable x and the dx. So y dx, the value of dx equals to v dx, v dy plus y dv. Then equals to x dy. So x, the value of x is dy. So dy, the dy is plus square root of y squared minus the value of x equals to v squared y squared. Then dy. Okay. Then distribute the value of y. So dy plus y squared dv equals to dy plus square root of y squared minus v squared y squared dy. So since they are the same, we need to cancel this one, is it out? So the remaining is y squared dv equals to, so the factor of y squared minus v squared y squared equals to factor y square root of y squared square root of 1 minus v squared dy. Okay, so since we have been factored out, so next is, so it becomes y squared dv equals to y, because the square root and 2 becomes 2 over 2 equals to, the remaining is y. So square root of 1 minus v squared dy. So next is we need to divide by y squared. Divide the square root of 1 minus v squared. Then y squared square root of 1 minus b squared. So cancel out, cancel the y squared. So the remaining is 1 over square root of 1 minus b squared dv. And the remaining of this one is cancel. So dy over y. So proceed to integration. So integration 1 over 1 minus b squared dv equals to dy over y. Yes, integral dy over y. So since this is integral trigonometric, so integral of du over square root of a squared minus u squared. So this is arc sine negative 1 u over a plus c. So we need to, the integration of this one is sine. Answer is sine negative 1 over v plus, so dy over y integral equals to ln y plus c. So since we have been following the x equals to dy, so we need to value also the v equals to y equals to x. So we need to change the variable v. So sine 1 over y over x, negative 1 y over x plus ln y plus c. So this is the final answer. Sine negative 1 y over x plus ln y plus. So for now, we need to proceed to solving in separable differential equation. So problem number 1, dy over dx equals to x squared over y squared. So at the left side, we only need the variable y, and the right side, we only need the variable x. So first, we need to cross multiply. So y squared dy equals to x squared dx. So we can easily integrate the y squared dy equals to x squared dx. So integrate. So integral of y squared dy equals to integral of x squared dx. So the integral of y squared equals to y cubed over 3 equals to integral of x squared. So x cubed over 3 plus c. So we can also divide side by 3. So 3 divided equals to y cubed equals to 3 divided by 3 equals to x cubed plus c. Or we can put square root of 3 is square root of y cubed equals to square root of x cubed plus c. So answer is 1. Answer is y equals to 3 square root of x cubed plus c. So that's the final answer. So let's proceed to another problem. Y prime equals to x1. So x1. So let's change the y prime equal dy over dx. So dy over dx. equals to xy. Then multiply both sides by dx. So that cancel this one. So the remaining is dy equals to xy dx. Then divide both sides by y. So that cancel this one by 1. So the remaining is dy over y equals to x dx. So we can easily integrate this dy over y equals to x dx. So integral of dy over x and integral of x dx. So the integral of dy over 1 equals to ln y, and the integral of x dx equals to x squared over 2 power rule. So x squared over 2 plus c. Okay, so next for the comes the a equals to a. So ln y equals to a x squared becomes to 1/2 x squared plus c, or a ln y equals to a 1/2 x squared times ac, so that we can obviously cancel out. So y equals to a 1/2 x squared times ac. So we can move this into the first. So y equals to a to c 1/2 x squared. So we have been given the y equals 0 equals to 5. So the y equals to 5 and the x equals to 0. So y equals to 5. 5, we need to get the value of c, the constant. So 5 equals to c a plus to 1/2 the value of x equals to 0 squared. So 5 equals to c plus to 0 so c equals to 5. So let's go back to the y equals to a 1/2 x squared ac, or y equals to c equals to 1/2 the value of c equals to 5. So 5 a 1/2 times a 1/2 c equals to 5. Then let's back to y equals to c 1/2 x squared. So the value of c equals to 5 a 1/2 x squared. So that's the final answer. So this is the other problem. So dy over dx equals to y squared plus 1. So we need y1 equals to 0. So we are going to put y1 equals to 0. Then first we need to multiply both sides by dy over dx, multiply by dx y squared plus 1 dx. So cancel this one, So the remaining is dy equals to y squared plus dx. Okay. Then y squared plus 1 again. Now then let's divide both sides by y squared plus 1. Y squared plus 1. So cancel out the y squared. So the remaining is 1 over y squared plus 1 dy equals to dx. So that's only the remaining. So we can use integration. So integration. So since the 1 over y squared plus 1, the tangent negative 1 is equals to 1 over 1 plus x squared. So we can use the tangent negative 1 y equals to the integral of dx equals to x plus c. Then we can multiply by tangent in each side. So tangent 1 multiplied by tangent negative 1y equals to tangent x plus c. So cancel the tangent. The remaining is y equals to tangent x plus c. So since we have given the value of y equals to 1 equals to 0, so y equals to 0, 1 equals to tangent, the value of x equals to 0 plus c. So since the value of y1 equals to 0, so the y equals to 0 equals to tangent, the value of x equals to 1 plus c. So 0 equals 0 tangent equals to 0. So 1 plus c equals to 0 also. Then c equals to negative 1. So that the value of y equals to tangent x plus 1. The final answer is y equals to tangent x plus 1. So proceed to problem dy equals to dy over dx equals to x cosine x squared over 4y. So let y 0. So first we need to cross multiply by this one. So dy times 4y equals to 4y dy, then dx times x cosine x squared equals to x cosine x squared dx. So okay, we can integrate both sides. So integral of 4x dy and integral of x cosine x squared dx. So the integral of 4y dy equals to 2y squared equals to, then the integral of cosine x squared dx. So let u equals to x squared, du equals to 2x dx. That's why 2y squared equals to the value of 2x dx. So 1/2 the integral of cosine equals to sine x squared plus c. So we need to divide by 2 so that we can cancel. So the remaining is y squared equals to 1/2 sine x2 plus c. We can also use the by this one. So over 2 the square root of y squared, so cancel. The remaining is y equals to the square root of 1/2 sine x squared plus c over 2. So the final answer is y equals to square root of 1/2 sine x squared plus c over 2.